Okay, this is part 2 of our inclined plane video, and we were working on this, and we just found that the base of this ramp is 24 foot long, and we need to find the length of this slope part, which is going to be our DE. So in order to do that, we're going to use good old Pythagorean theorem, a squared plus b squared equals c squared. A and b are 2 and 24, and put that in your calculator. And 2 squared plus 24 squared gets us 672. And that equals c squared. So then how do we find just c? Well, remember we take the square root. And remember, really, from Algebra 1, we'd say plus or minus here. But can the length of this ramp be a negative? No, so we don't need to worry about that part. And when we do the square root of that, we get 25.93 equals c, and that should make sense because our hypotenuse needs to be slightly longer than the other sides. So 25.93 feet is a reasonable answer. Now let's find our ideal mechanical advantage. IMA equals DE over DR, or we could use the formula L over H. DE and L are 25.93. and H was the 2 foot right here. Divide that and we get 12.96 feet. I'm sorry, not feet. 12.96 is our mechanical advantage. Almost a mechanical advantage of 13. That's really good, and the place that we see that is when we start looking at how much would it take to push someone in a wheelchair up the ramp. Well, we say that the combined weight of a person in the wheelchair is 185 pounds. This right here is our FR. And so we're going to use our AMA equals FR over FE. AMA is the same as our IMA, 12.96. FR is 185. How much effort will it take to push this person up the ramp? Well, you multiply this over here, divide that over there. FE, cross multiply, right? We get FE as 185 divided by 12.96. And we find that it's only going to take 14.27 pounds. This is really nice. And remember, we were talking about ADA code. This is really nice because it says it only takes 14 pounds of pressure to push someone up this ramp. What that means is someone who is not very strong, who's in a wheelchair and having to roll the wheels of their own chair, only takes 14 pounds to do it. Or it could be even that it's a child pushing an adult up this ramp. And the person doing the pushing does not have to be very strong because we've made the ramp a very low slope. Okay, that's it for inclined planes.